All right, intervention video time. Okay, still going to be running these on topics that people either request or I feel like we might need or anything like that, because it's still good to know the content of the course to a very good degree. So this is going to be everything you could want to know about algebraic proofs. Okay. And algebraic proofs were a thing that we looked at over the first lockdown, actually, when everyone was starting to come back into school. And we ran a couple of sessions, and this was one of the things we looked at. Okay, and so let's take a look. So, jumping straight into algebraic proof, the kinds of questions that you might deal with could potentially be wordy, or they could be written algebraically. The kind of question that we've got here, which says prove that if you take two consecutive odd numbers, square them and add them together, you will get an even number, is a very classic kind of algebraic proof question. Okay, it's something that if you were to just rely on trying out numbers, you would get nothing for the question, okay? The key words in that is the prove, okay? We need to start from scratch, okay? If a question says show something, we can, use some numbers, make it work. Or perhaps start with something that we're given and make something work. But the fact it says prove means that we have to start from scratch. Okay? And the steps to go through an algebraic proof normally rely on these four things. Okay? Finding your expressions, step number 1. Expanding any brackets, step number 2. Simplifying, and then possibly factorizing. Okay, I put a question mark on this one because this one sometimes isn't necessary, sometimes it is. Okay, so we need to start with this first point, finding your expressions. Now, for algebraic proof, there are certain expressions which are particularly useful. Okay, and these might be some of those expressions. Now, these are the kinds of things that flashcards are ideal for. Okay, knowing what these expressions are will open up the algebraic proof questions and give you a chance at being able to answer them. Okay, if you can't come up with these expressions, some algebraic proof questions will be extremely difficult. Okay, not impossible, but extremely difficult. Okay, so we're going to take a look at them now. These are some things which are really important. If we're talking about any number, and for proof we'll be talking about whole numbers, not decimal numbers, we'll be talking about whole numbers. Okay, if we want to talk about any whole number in an algebraic proof, we would use n, or any letter. If we wanted to talk about any other number, like literally any other number, we could use any other letter. Okay? Consecutive is a word that means to kind of follow one another. Okay? So if we talk about things that are consecutive, they follow one another or they are next to one another. Okay, so if I'm talking about consecutive integers or two consecutive integers, I'm talking about one number and the next whole number. So that might be n for any number, and then n plus 1 for the next whole number. Two things which we could use quite a lot within our algebraic proofs are talking about odd numbers and even numbers. Now, even numbers are numbers that are multiples of 2. Okay? So if something is a multiple of 2, it's an even number. So 2 times something will make something even. An odd number is a multiple of 2, then add or subtract 1. For instance, if I take any multiple of 2, say 14, an odd number will be either side of that 14, so either 13 or 15. So an odd number is an even number, add or subtract 1. Okay? Normally, I would say deal with the add one because it will keep things positive, and generally positive things are easier to work with. Multiples of 3? Well, if a multiple of 2 became 2 times a number, a multiple of 3 would become 3 times a number. Okay? And if we wanted to kind of stretch this even further, we could say, what about a multiple of k? Well, that means we would just say a number times by k, or km, or kn, or anything like that. Okay? Sometimes our expressions might get that little bit more awkward. Consecutive odd numbers being one of those ones which might be a little bit more awkward. Well, one of my odd numbers, as we've seen above, can be written as 2n plus 1. If I had 2n plus 1 as a whole number, an odd number, and I wanted to get to my next odd number, I would have to add another 2. Because if I added another 1, I would get to an even number, and adding another 2 would get me to the next odd number. Okay, so I could have 2n plus 1 plus 2, which, you know, we're higher tier mathematicians at this point. We should simplify that. It's 2n plus 3. Okay? And we can use the same idea almost to think about the last one. The next multiple of 3 to 3n. Well, if 3n is a multiple of 3, the next multiple of 3 would be 3n, add another 3. Or 3 lots of n plus 1. Okay? Now, I'm focused a lot on these things here because these are the kinds of things that open up those proof questions, okay? And if we look back to that question that we had right at the very start, prove that if you take 2 consecutive odd numbers is one of those expressions that we had, okay? So if we don't know what those expressions are, we can't even do the rest of the question, okay? So you must know what these expressions are. Make a flashcard for them. Test yourself on them, okay? See if you can write them down off the top of your head in a couple of days' time, okay? These are the things you need to kind of know. And once we know what these expressions are, we need to see what we're doing with them, okay? And so we need to be able to also work with expanding any brackets and working with those kinds of expressions as well. Okay, so what we're going to do is we're going to take a look at the kind of expanding, simplifying, and factorizing that we may have to do, and then come back to this situation to show how we can put it all together to do a top tier proof. Okay. So this is going to show us the kind of expanding and simplifying and factorizing that we may have to do. Okay? Prove that 5n plus 1 all squared, take away 5 and take away 1 all squared, is a multiple of 4 for all positive values of n. Okay? Now, the expressions we've already been given. We've been given at the top what to start with. So that's a good thing. Okay. After we've got what our expressions are, we normally look to expand. So I need to expand both of those brackets. Okay. So 5n plus 1 all squared would be that bracket multiplied by itself. And we've done loads of expanding brackets at this point, so we should know how to do that. This is what we should get. And again, if I take that second bracket squared, multiply it by itself, expand those two brackets, this is what we would get here. These two brackets are being taken away from one another, so we need to do that. So 5n plus 1 all squared, take away 5n, take away 1 all squared would be this thing. Now, be careful, okay? When I kind of look at this all in all, I'm going to have 25n squared plus 10n plus 1. That's straightforward enough. But this negative sign is going to affect all of those three things. I'm going to have take away 25n squared, take away negative 10n, which is going to make positive 10n, and then take away 1. And it's this simplifying here that gives us 20n. Okay, now, we've done our expanding. We've done our simplifying. Now we need to think about factorizing. So we need to look at what we need to prove. We need to prove that it's a multiple of 4. Now, if you remember back to our expressions, a multiple of something means that we can write that number times by something else. Okay? And in our factorizing, what that means is, can we take a 4 outside of a bracket? And in this case, we can, because 4 is a factor of 20. So we can take 4 outside of a bracket to make 4 lots of 5n. And we can say, therefore, the expression is a multiple of 4. Happy days. Okay? So this is the kind of thing that we might need to do in terms of our expanding, our simplifying, and our factorizing. Okay? So, at this point, if you're following the video as is, you might want to pause it here and have a go at this question at the top, following the structure that we've got on the left, and see if you can do this question, which is similar, but again, slightly different. Okay? If you want to try it out, press pause. I'm going to give you 5 seconds to do that, and then I'm going to reveal the answer. Okay, so hopefully you've had a go at that question on the right, and that box does not move. Okay, let's get rid of the box then. Awkward. Oh, it's because I need to click reveal. There we go. So, expanding our brackets, just like before. Simplifying our expression, be careful with the negatives, just like before. And then factorizing to show that we have it as a multiple of 6. So that 6 has to be factored outside of those brackets. Okay? So, those are the kind of skills that we will need. We do now want to see how to put that into a top-tier algebraic proof. Something like this. Okay? So, prove that if you take 2 consecutive odd numbers, square them, and add them together, you will get an even number. Step 1. Find your expressions. Okay? We need to come up with our own expressions because we've not been given them. We're talking about 2 consecutive odd numbers. So I need to make sure that I write those things down. 1 odd number is going to be 2n plus 1. The next consecutive odd number, as we wrote down earlier, would be 2n plus 3. Okay? We need to know those expressions. We're taking those two numbers and we are squaring them. Okay, let's do that then. So we're going to have 2n plus 1 all squared and 2n plus 3 all squared. We have found our expressions that we need to use. Next step, we're adding them together, okay? And then we're going to have to move on to step number 2, which is expanding those two brackets. So here we go. We've got 2n plus 1 all squared. Okay. Now that's the same as 2n plus 1 bracketed with 2n plus 1. And again, we've done expanding brackets a million times, so I'm just going to say that that's 4n squared plus 4n plus 1. And we've also got 2n plus 3 all squared, which is the same as 2n plus 3, 2n plus 3, which is 4n squared again. Now, 2n times 3 would be 6n. Add another 6n, which is going to be 12n. And then 3 times 3 is 9. So we expand our brackets. Next stage, simplify. Okay, we need to find out what 2n plus 1 all squared plus 2n plus 3 all squared is equal to. Well, that's equal to 4n squared plus 4n plus 1 plus 4n squared plus 12n plus 9. Simplify it. Well, the brackets in this case, because it's just a plus in the middle, there's no weird stuff going on with our negatives. So it's just going to be 4n squared plus 4n squared, which is 8n squared. 4n plus 12n, which is 16n. And 1 plus 9, which is 10. Now, here comes our last stage. We want to prove that we get an even number. And for us to have an even number, what we need is we need to show that it has a factor of 2. Okay, that we can take a factor of 2 out of everything. Well, 8n squared divided by 2 is 4n squared. 16n divided by 2 is 8n. And 10 divided by 2, that kind of says plus 2, is 5. So we can take a factor of 2 out, which makes it even. Okay? And we've completed our proof. Okay, this is the kind of top tier proof that we might need within higher tier. Okay, and we might use different kinds of expressions, and that's why knowing these things is so important. Okay, so I also want you to go and practice things, okay? And practicing things is really important, okay? There are two things that you could possibly practice depending on what kind of, tier of question you want to look at. You've either got these things here, which are here's an expression, I want you to do the algebraic work, okay? I want you to do the expanding, the simplifying, and the factorizing to get your answer. Okay, there's this, or there is a separate worksheet in the same file as this, in the same folder as this video, okay, which has got some more kind of top tier proof questions in there, and you can feel free to have a go at those. The answers are combined with that worksheet. Okay, the answers for these questions are further along in the PowerPoint, and the PowerPoint will be in the same folder as this video as well. Okay, I thought I'd just introduce this as a kind of remember this. This is the thing that we need to know. And if we don't know those expressions, then we can't do these questions most of the time anyway. Okay? And final thing before I sign off this video, be mindful and be aware of the steps that are involved in a proof. Find your expressions, expand any brackets, simplify your expressions, factorize if you can. Okay? Right, I'm going to leave it there. I hope you find this useful as a good reminder. And if you do any of the work that are in these intervention videos, then upload a photo of it, stick it in your student work folder on Teams, okay? And that way I can see just what is you're actually getting up to with your intervention videos, okay? And it's great evidence, okay? So if you are getting on with these intervention videos and you are doing work for them, put some evidence into your student work folder, okay? I'll see you in one of our live lessons. Ta-ra.